Hello everyone, welcome back. In this video we are going to look at the solution for question 9 and the question 10 on the January 2023 CSEC Mathematics Paper 2. We begin by looking at question 9. We have a circle theorem diagram with an angle Z marked. Notice that we have a tangent, we have a chord, and we have a diameter. And so it says W, X, and U are points on the circumference of a circle. TV is a tangent to the circle at U. UW is a diameter. And we're asked to state three reasons why that explain why angle Z is 45 degrees. So we are told that this angle here is 45 degrees, and we are to suggest three reasons why this may be so. First, let's note a few things. Note that WXU is an isosceles triangle, as mentioned here. And from what we know, the angle drawn on the diameter, or the angle drawn in the semicircle, is a right angle. That means that this angle here is a right angle. And because the triangle is isosceles, then this angle here is 45 degrees. And this angle here is 45 degrees. So that said, the first reason we want to look at is that the angle between the tangent and the chord. So I'm just going to highlight that by painting it red. The angle here between the tangent and the chord. So here's a tangent, here's a chord, and that angle is equal to the angle drawn in the alternate segments, this angle here. So those two angles are equal to each other, and that is one reason that this angle Z is 45, because that angle there is 45. Second, the tangent meets the radius at the point of contact, creates a right angle. So there's a right angle here as well. And if there's a right angle here, and this angle here is 45, then the other part of the angle has to be 45, because then we're going to have 45 plus 45 here to give it a full 90 degrees. That is the second reason that we're looking at by for Z being 45 degrees. And then the third reason could be that looking at the diagram, that this angle TUV is a straight angle. I have a right angle here that is not what I intended to write at all. So TUV is a straight angle. Let's get rid of that. Straight. So TUV is a straight angle, and because it's a straight angle, it measures 180 degrees. And that 180 degrees, notice here that on this side of the angle, we would have a 90 degree here and a 45 degree here. 90 plus 45 here would give us 135. And so the other part of the angle there would be 180 minus 135, and that gives us 45 degrees. So TUV is a straight angle. That's our third reason, I'm sure. There may be other reasons, and you can suggest those in the comments if you have other reasons that you think are worthy. I will surely pay attention to them, and we can share those with others as well. So those are three possible reasons that we have that this angle here is 45 degrees. Let's look at our next question, or next part of the question. Another circle theorem diagram. Diagram below shows a circle with diameter FK or KF, and the line EFG is a tangent to the circle at the point F. F, H, and K, J all lie on the circumference. So we are asked to find, by showing the steps in our work, the size of angle X. Now angle X here, there's a theorem that states that the angles drawn in the same segment are equal. So here we have a segment, and here we have the alternate segment. And notice that these two angles are drawn in the same alternate in the segment alternate to this. So for that reason, these two angles are equal to each other. So we can just write that down, that angle X is equal to 56 degrees. And it is 56 degrees because they are both in the same segment. So angles in the same segment. And of course, they're equal to each other. All right, so that's our reasoning, and that is the answer, 56 degrees. Next, we want to find y. To find y, notice that we have a triangle here. I'm going to just separate this triangle and draw it out here. So here we have that line, and then we'd have another line going there, and then this line coming here. So the measurements on that are x here, which would be 56, and 19 here. And so we have angle y there. Now there's a theorem on triangles that state that these two angles here, if you have an exterior angle drawn, it's equal to the sum of the angles here. But rather than using that theorem, so I could write it down. So y is equal to 56 plus 19, and 56 plus 19, of course, 50, 60. That's 75 degrees. But if you want to look at it another way, then notice that the three angles in a triangle add to give you 180 degrees. That means this angle plus this one, plus this angle that we don't know yet, all add to give 180 degrees. Now 56 and 19 is 75. And so to get our third angle here, we would say 180 minus 75, which gives us 105. And then notice here that this angle is a straight angle. And because this is a straight angle, it measures 180 degrees. So we can then say y is equal to 180 minus 105. And of course, that gives us 75. So there are multiple ways of looking at it. Either way, our answer is 75 degrees, and we have some workout for that as well. Moving on, we have the diagram here below shows 4 points, P, Q, R, and S, and these points are on level ground. So in your mind, you need to imagine this as flat and on a flat surface, even though it doesn't look like that when you draw it. And it says there is a vertical post RT at R. So there's a post here, a vertical post. From angle Q, the angle of elevation to the top of the post is 21. Find the height of the post. So we're supposed to put a post here, and that post is RT. Now we have R, so the top of the post would be T. And so let's try to draw a post there. So the post would go here. And then the angle of elevation measured from the point Q to the top of the post, T. So measured from the point here to the top of the post there. The angle of elevation is 21 degrees. Now, like I said, it's a little odd looking at it. So I'm going to try to draw the triangle again by drawing something like this. Well, let me use this other line, which is a better line to use. So here we go. And here we go. So here's our triangle. And this is R, this is T, and this is the point Q. Remember, it says that Q and R are on a flat surface. So this here and straight line, and TR is vertical, is a post in a vertical position, which means that this angle here is 90 degrees. Now we have this number, 153, and we need to find the height of the post. So I'm just going to call it H, although we could use it as TR. So this angle being 21, notice that we're using this side, H, which is the opposite side, and we're using QR, which is the adjacent side. And that tells us that we should use the tangent ratio, because tangent of the angle is equal to the opposite side divided by the adjacent side. And so we can write it as tangent of 21 is equal to TR, which is the height of the post, divided by 153. Once we do that, we can quickly cross multiply it and write 153 times the tangent of 21, and that would give us TR. And of course, TR then is equal to once you punch it in your calculator, and make sure that you have your calculator in degree mode. And that gives us, of course, 58.7 meters. And that takes care of the height of the tower, of the post rather, not the tower. Okay, let's move on to the other part of the question. And I have this diagram here, which I should have mentioned. So I'm going to go back here and look at this so you can probably see it a little better. So this is QR, and I'm going to label this as this is a QR here. And so the post, just for better viewing, the post being vertical would actually be here. So if you look at it this way, you can actually see it looking a bit vertical, because this diagram is drawing a way to make it appear in a better way that P, Q, R, and S are on a flat plane. And once you do that, then you can see it a little better, that the angle of elevation here, let me just put that in a different color. So here the angle of elevation being 21 degrees, and this is 153, and there's your right angle. So it looks a bit easier to see here, but it's the same thing that we tried to do here by drawing the triangle separately. But this diagram is just intended to give you a better view of it, where you can probably see it a little more, that this is a flat plane. These are our points P, Q, R, and S, and this is our vertical post RT on the flat plane. All right, let's move on now. So we're given that QS is 135. QS is 135. So this is QS, it's 135. We want to work out the perimeter of the foundation. Perimeter of the foundation. And just going back here, the perimeter of the foundation would be all these sides, adding up all these sides. And so we're going to add QR to RS, QP, and PS. So the perimeter is equal to, starting here, 83 plus 153 plus 110 plus PS. And notice that we do not know PS, but we're given information to calculate the length of PS. Now notice here that you have a triangle with two sides, an angle between, and we're asked to find PS. So that there tells us that we should use the cosine rule. And the cosine rule may be written as a square equal b square plus c square minus 2bc cos a. And so we're going to be treating it this way. So PS square is equal to these two sides, 83 square plus 135 square minus 2 times 83 times 135, and the cosine of the angle between them, 29. And of course, all you need to do in this day and age is just to type that in your calculator exactly as is. No need to break it up and find them individually pieces. And once you do that, your answer here should be 5,513.8. And then, of course, because we want PS, then we find the square root. PS is equal to the square root of 5,513.8, which is approximately 74.3 meters. So now that we know PS, we can add this 74.3 there. And so our perimeter being 83 plus 153 plus 110 plus 74.3 gives us 420.3 meters. That takes care of our perimeter distance around the foundation. Moving on to our next question, number 10. We notice that we have three matrices here, Q, R, and S. Q is a 2 by 2 matrix. R is also a 2 by 2 matrix, and S is a 3 by 2 matrix, meaning that we have 1, 2, 3 rows, and we have 1, 2 columns, and that is how we read it: 2 rows, two rows, 2 columns, row, column. So that is how we read it. First number is a row, second number is a column. So it says explain why the matrix product QS is not possible. So if we're going to try to multiply QS, then Q is a 2 by 2 and S is a 3 by 2. Now, one rule that we use to decide if two matrices can be multiplied together is that we write out the order of the matrix like this. Now, this description, the number of rows and columns, is what we call the order. Rows and columns. Rows and columns. That's what we mean. So the order LNS column. So the order here simply means how many rows and columns it has. So what we do to check if they can be multiplied is that we look here on the inside at these two numbers. And if these two numbers are the same, then it means that they can be multiplied together. And if they're not the same, they can't be multiplied together. So once you check these two, if they are the same, they can be multiplied. So same is yes, and different is no. If you want to write that out, then what it's saying is explain why the matrix product QS is not possible. So remember we said this is row and this is column. So row, column, row, column. This is the rows, this is the columns. So the number of rows in Q, number of, I wrote that incorrectly. Row, column, and row, column. Row, column. Let me tidy that up, because the way it's written there is a bit distracting, and I do not want it to be distracting at all. I want you to get it clearly. So let me tidy it up. All right, so let's write it again. So this is a row, this is a column, this is a row, this is a column. So the idea is, if the number of columns in the second, number of columns in the first matrix, the number of columns in the first matrix is not the same as the number of rows in second. So the number of columns in Q is not the same as the number of rows in S, and that is why it's not possible to multiply. And in that case, you'll have a mismatch when you're trying to multiply them. So we should state the order of matrix SR. No. So let's write down matrix S. Matrix S has 3 by 2, and matrix R is a 2 by 2. Now again, let's check it. So the inside numbers, as we mentioned, if you check the inside numbers, row, column, row, column. So the number of columns in this is the same as the number of rows in that. That's a yes. So it means that you can multiply them. Now, the other part of the numbers, these numbers on the outside, what they tell you is what the order of the answer will be. That is, remember the order of the product. And that simply means how many rows and how many columns the answer will have. So the order of the product will be 3 by 2, meaning that the product is going to look like S. The product will look like S. It will have 3 rows and 2 columns, just like S. The order of the matrix is the number of rows and columns that it has. The order of the product is the number of rows and columns that your answer matrix will have. So this is exactly what that is talking about. Moving on, we are to calculate the matrix product QR. So let's write them down and multiply them out. So the matrix product QR, let's just write Q. Q is 2, -1, 4, 3, and we're multiplying that, of course, by 1, 6, -5, 4. Okay, let's go ahead and multiply. So we're going to multiply row by column. So this row multiplies that column. So we have 2 times 1, that's 2, plus, and it's always plus, -1 times -5, that's 5. Then we have this row times this column, 2 times 6, that's 12, plus -1 times 4, that's -4. Next we go to the second row, 4 times 1, that's 4, plus 3 times -5, that's -15. And this row now times this column, first to first, second to second, 4 times 6 is 24, plus 3 times 4 there gives us 12. And so we can tidy this up and write it as 2 plus 5 is 7, 12 minus 4, 12 plus -4, same as 12 minus 4, that's 8. And 4 plus -15 is the same as 4 minus 15, that's -11. And 24 plus 12, of course, is 36. So that is our answer there. And part B says that given that A is this, determine the value of X if the determinant is 5. The symbol here means the determinant. So let's first write down the determinant of A. So determinant of A is going to be equal to 4 times X minus -1 times -7, which is simply 4x. Negative times negative here is positive, so we're still subtracting 7. So now we are told that the determinant is 5. So this is the expression for the determinant. So we know that 4x minus 7 is actually equal to 5. This gives us a simple linear equation. So we go ahead and solve it. So it's 5 plus 7. So 4x is equal to 12. And therefore x is 12 divided by 4, which is 3. So that is the answer part of the matrix part of the question that we were working out. And we move on to the other part of the question, which is a vector part. And what we notice here is that in the diagram we have OPQ, is a triangle, OPQ, and ARB, and AOQ, that's A, R, B, and AOQ, that's these two lines, are straight lines. B is the middle of PQ, halfway point. R is the middle or midpoint of AB. And OR to OP, that is the ratio of OR to OP, is 1 to 3. All these are important information that we need. Now, OP is equal to 4A. OP is equal to 4A, and notice we have a ratio here that tells us how the line is divided. So this is one part of the line, that's 3 parts of the line. Together we have 4 parts of the line, 1 part here, 3 parts there, corresponding to 4A. So that tells us clearly that this section is A, O to R is A, and R to P is 3A. And notice it said the vector OP, which means that we're going in this direction. And that is important to remember. And OQ, from O to Q here, is given as in that direction, A to B. Direction is very, very important to vectors. So first we want to write in terms of A and or B in its simplest form, PQ. So the question is, how do we get from P to Q? Now, when you're doing vectors, it's important to understand that if you are going from P to Q here, pretend that this is a road, this is a route, that route is blocked, and you can't travel there. So you have to find a different route. And in finding a different route, that is how we come up with the answers for our vectors. So here, PQ, to get from P to Q, since we can't travel this way, we have to go back PO, and then from O to Q. Now we could go PO, PR, RA, then OQ. that would be viable, but except that we don't have any measurements for these. All right. So because of that, we simply go P to O and then O to Q because we have something to use here. But if there was something out there, you could have used that direction, that route as well. A bit longer, but in vectors, the length you go doesn't matter. It's not like in measurement where the length matters. In this topic, how far you travel doesn't matter as long as you get to the place you're going. So we have PO, OQ. Now, PO, to get from P to O, remember that this vector is given as OP. So the arrow is facing that direction. We want to reverse it, which means that because all of this was 4A, we want to reverse it and use it in the opposite direction. So it's going to be minus 4A. And then we are here, we're going in this direction, and that's 8B. Now it says in its simplest form, so normally I would leave it as that, but you could rewrite it as 8B minus 4A. And if you want to be fancy about it, then you could factor out a 4 and write 2B minus A, and that would be the same answer, depending whichever one makes you feel better. So here we have PQ, that's what PQ is. We're going to move on to the other part. We want to find PR. Now remember, this was A. This was 3A. We just calculated this part as 8B minus 4A. 8B minus 4A. So that's this. That's PQ. And now we want to find PR. So how do we get from P to R? P to R is quite simple in this sense because we have our vector going from O to P, and that was equal to 4A, the entire thing. But RP was 3A, and now we want to reverse it to find PR. So since RP is equal to 3A, we simply reverse it and say PR is equal to minus 3A, since we're going in this direction. And that's that. The other part is to find RB. Now, how do you get from R to B? To get from R to B, we could use the root up here, since it's simpler. To get from R to B, we could say, all right, I cannot travel here, so I'm going to take this route, R to P, and then move from P to B. Now, RP, we know that to be 3A. And PB is half of PQ. And we're going to write half of 8B minus 4A. So let's tidy this up and work it out. So we have 3A there, plus half of 8 is 4, that's 4B, and half of 4 is 2. So that's minus 2A. And doing some subtraction here, 3A minus 2A, that gives us A, plus 4B, and that's what RB would be equal to. So RB is equal to A plus 4B. That brings us to the end of our questions and the end of our paper. Thank you for watching. Remember, you can find more past and practice papers on our website at csecmathtutor.com. You can also find other solutions there, as well as help with things like SVA and other things. So until next time, thank you for watching.